Okay, I think we are live. Yeah. So, so in the stream, I want to basically watch this podcast. I watch this talk, Andrej Karpathy, and he's a big figure in AI, and he's a co-founder of OpenAI, and he's a work at Tesla, and if you search him on the internet, you will know how good he is. And he gave a talk. So each time, obviously you have to take serious about his opinions about AI and stuff like that, because a lot of the times his opinions was right. And he's the one actually made this term vibe coding. Actually, he's the one named that uh, style of coding as a vibe coding. And um, so I think it is interesting and fun to watch his talk. um, so that is one thing though, before he's giving a talk about how to how AI model works and stuff like that. But nowadays his talk is mostly about how AI is rapidly changing, how the coding, way of coding is changing and stuff like that. So he's one of the person in frontier, I would say. Frontier in a sense. He's not, I think currently he's not working at any uh, frontier labs or something like that. I think he's working on his phone or something like that. And so um wait a minute. So that thing, actually I think it is useful. Um Still, it is useful to hear his opinions about how things are moving. Um, so, okay, I haven't watched this video before. Actually, I only watched, I don't know, 4 or 5 minutes. So, actually, I'm not, I'm not prepared for this. I just, just watch the video and start the video and see what comes out of it. Okay, okay, let's start.
He has helped build modern AI, then explain modern AI, and then occasionally rename modern AI. He actually helped co-found OpenAI right inside of this office, was the one who actually got autopilot working at Tesla back in the day. And he has a rare gift of making the most complex technical shifts feel both accessible and inevitable. You all know him for having coined the term vibe coding last.
Actually, this is one of the funny thing about, like, when someone introduce you as like saying things about you, like what are the things you did. For me, at least, it's kind of feel like it is. I feel very nervous about it. Like, I don't know how to react it. Like, do I need to smile, or do I need to just stay calm, or do I need to say some jokes about it? So it is kind of funny, at least for me. I don't know how to handle this,
Year, but
but
just in the last
I think he's handling it really good.
few months, he said something even more startling, that he's never felt more behind as a programmer. That's where we're starting today. Thank you, Andrej, for joining us.
Yeah, hello. Excited to be here and to kick us off.
Okay, so just a couple months ago, you said that you've never felt more behind as a programmer. That's startling to hear from you, of all people. Can you help us unpack that? Was that feeling exhilarating or unsettling?
Yeah, a mixture.
To be honest, that feeling is not only for him. I think it is who are peoples who are using, who are also good at coding, also using AI, felt this. Like, now you have this I don't know, like have this immense power of doing things, doing different things at the same time. It does feel like a superpower or something like that. If you're really into coding and developing softwares, you kind of feel that, because before you have to write, I don't know, like maybe 2000 or 3000 lines of code per day. That is a decent amount. And that is not only a decent amount, it depends on the problem, right? If it is some kind of AI model, it's going to be, very way less line. If it is it depends on the product, whether if it is a software, what kind of software it is, web or operating system or compilers, whatever it. But uh so so it is like you can only quality amount of code, like just a specific chunk of code. It is somewhere around 2k, some 2k to 2.5k, something like that. But now you have this immense power. So you don't know what to do with it, because most of for me it's like each time I do coding, and most of the time I feel like I have to do more. I have to do more. It is not enough. It is not enough, because this loop of constantly getting things done. Okay. Just give a prompt, give a specification, give a configuration, and launch a agent, then done it, then move on to the next. It's just a constant loop of getting things done. Next what? Next what? Next what? So I feel like I'm really going fast. At the same time, I don't understand anything in the end. It's like it is like it is like I'm doing things really fast, but still I don't understand what I'm doing.
Sure, both for sure. Well, first of all, I guess like as many of you, I've been using agentic tools like Cloud Code, adjacent things for a while, maybe over the last year as it came out, and it was very good at chunks of code, and sometimes it would mess up and you have to edit them, and it was kind of helpful. And then I would say December was this clear point where for me, I was on a break, so I had a bit more time. I think many other people were similar, and I just started to notice that with the latest models, the chunks just came out fine, and then I kept asking for more, and it just came out fine, and then I can't remember the last time I corrected it. And then I just trusted the system more and more, and then I was vibing.
This is the scary thing to hear, at least for me, because someone like him, I really admire him, of his work, about like specifically about his work in YouTube and Twitter. His tweets are really good, and his YouTube content is, I don't know, it's insanely good. It's insanely good because he's yeah, it is insanely good because he have such experience in the field, and he's one of the big figure, and he also teaching you things like uh in a very simple and understandable way, that and it have such a high quality thing. So that is insanely good. And yeah.
Coding, and so it was kind of a
So for me, at least, a person like him saying that I can't remember when I was check my coding, check my code. Uh, so it is it does feels uh, um, very uncomfortable for me, because um, it kind of implies that uh, coding, it kind of, for someone like him, he have to be care about what he is actually coding, right? Do actually programming and stuff like that. Even himself doesn't check and check the coding and review it and stuff like that. It does feel very uncomfortable, because it's create this weird feeling of weird question, like, does AI becomes that good, so that you no longer need it? So that is the root cause of this fear about job loss and stuff like that. We are going to talk about this later, but it does feel very uncomfortable.
I do think that it was a very stark transition. I think that a lot of people actually, I tried to stress this on Twitter and or X, because I think a lot of people experienced AI last year as ChatGPT adjacent thing, but you really had to look again, and you had to look as of December, because things have changed fundamentally, and especially on this like agentic coherent workflow that really started to actually work. And so
Yeah, yeah, that is actually quite true because uh ChatGPT movement was the first one. Everybody experienced how AI, what exactly AI is, but this Codex and Cloud Code, and Gemini, CLI, and these open code, and these tools actually really good. And these tools actually second movement of ChatGPT movement, because if you look at the rest of the world, there is so many people actually they don't even care about what is this AR, and what how the world is changing and stuff like that. So many people, right? I think I'm in India. So if you look at India, India is one of the largest one of the country has a large amount of software developers and stuff like that, but still it lags behind from US and stuff like that, because those countries people are much more in very cutting edge and stuff like that. But I'm not sure, but what I'm saying is that it does not affect the entire world. The AI revolution is not affecting the entire world, but instead, but the impact it gave to specific field, field like software development is huge. It's like insanely huge. It's like it's like this is the specific chunk of time, like 2023 2022 to 2026. It just completely changed you so many things in a specific period of time in the specific field called software development and software programming and stuff like that. It just completely changed, completely. So many things. It just the change is insane. The rate of change is insane.
I would say that, yeah, it was just that realization that really had me go down the whole rabbit hole of just infinity side projects. My side projects folder is like extremely full with lots of random things, and just vibe coding all the time. So yeah, that kind of happened in December, I would say, and I was looking at the repercussions of that since.
Yeah, that thing is actually true, even for myself, because my folder about side projects is there is a lot of random things, and a lot of things that is half complete. A lot of things just started and just gave up, and you know it is true.
You've talked a lot about this idea of LLMs as a new computer, that it isn't just better software, it's a whole new computing paradigm. And software 1.0 was explicit rules, software 2.0 was learned weights, software 3.0 is this. If that's actually true, what does a team build differently the day they actually believe this?
Right. So, yeah, exactly. So software 1.0, I'm writing code. Software 2.0, I'm actually programming by creating data sets and training neural networks. So the programming is kind of like arranging data sets and maybe some objectives and neural network architectures. And then what happened is that basically, if you train one of these GPT models or LLMs on a sufficiently large set of tasks, implicitly, because by training on the internet, you have to multitask all the things that are in the data set. These actually become kind of like a programmable computer in a certain sense. So software 3.0 is kind of about, your programming now turns to prompting. And what's in the context window is your lever over the interpreter, that is the LLM, that is kind of like interpreting your context and performing computation in the digital information space.
Yeah, this think about like software 1.0, 2.0, 3.0, and this is yeah, he's the one actually term also coined this term called software 2.0, and now it is software 3.0. Basically what he's saying is that software 1.0 is basically you write code, you tell the computer what you have to do, like you give the instruction and the computer executes that. And the 2.0 is basically you don't give the specific information, you kind of like you have a data set, and you are training the neural net on it. So it is basically like, end of the day, it is the main thing about both 1.0, 2.0, 3.0 is that algorithms, right? So whatever you do, it is certain procedure, right? You can call it as algorithm, right? So 2.0 is basically you are not directly saying the algorithm, writing the algorithm. Instead, you are letting the computer to figure out the algorithm, like with the weights and patterns and stuff like that. So the neural net is basically trained on the data set, and it basically optimized to the lowest loss, and stuff like that, and then it predicts the thing, you know correctly. So it is basically figure out the algorithm in that how to predict this input to output match in a right way, right? That is the 2.0. Now the 3.0 is basically like the LLM itself is kind of like acting as a computer, right? So it is not like it is kind of like a more like an intelligent being, like so I think I can give you some analogy about like operating system, right? What exactly OS is something that maintains memory management and stuff like that. It is the main purpose is to manage memory, let's say. So now LLM can easily do that, right? Because LLM have this algorithmic sense about you can call it as algorithmic sense, or you can call it as a knowledge about how to handle memory, right? So now the LLM itself is acting as this, you are saying, before you are instructing, give instructions, instruction, I mean coding, right? You can think of it as assembly instruction or something like that. Now you're giving a prompt. Now it decide to basically do the things for you, like, okay, it have this knowledge and algorithmic sense about what to do when you give that prompt. Then it thinks, maybe, then it do it, right? But still, in the end of the day, it's all computing. And I would say it's a different way of interacting with the computers, where first you are writing instruction, second you're training with the data set and neural network. Then so first you are explicitly writing the algorithm, second you are not explicitly writing the algorithm, you are letting the computer to figure out it. And now the third is kind of like the compute and the LLM, the neural net is act as a um software, entire software unit. That is, I think, that is but I'm not sure whether it is the right point of view, but this is my point of view, that the third is basically act as an entire software unit. So it is the central unit. So you talk to it, it have this knowledge about no it have this knowledge about what to compute, how to compute, how to compute, sorry, how to compute and what to compute, and have this algorithmic sense about how different things are working and stuff like that. So it is kind of this organizing, it is kind of this act like a central or single unit that does everything. That is, I think, how this paradigm is shifting. That is, I think, what exactly he's mentioning.
So I guess, yeah, that's kind of the transition. And I think there's a few examples of that really drove it home for me, and maybe that might be instructive. So for example, when OpenClaw came out, when you want to install OpenClaw, you would expect that normally this is a bash script, like a shell script. So run the shell script to install OpenClaw. But the thing is that in order to target lots of different platforms and lots of different types of computers you might run in OpenClaw, these shell scripts usually balloon up and become extremely complex. But the thing is, you're still stuck in a software 1.0 universe of wanting to write the code. And actually, the OpenClaw installation is a copy-paste of a bunch of text that you're supposed to give to your agent. So basically, it's a little skill of copy paste this and give it to your agent, and it will install OpenClaw. And the reason this is a lot more powerful is you're working now in the software 3.0 paradigm where you don't have to precisely spell out all the individual details of that setup. The agent has its own intelligence that it packages up, and then it kind of like follows the instructions, and it looks at your environment, your computer, and it kind of like performs intelligent actions to make things work and debugs things in the loop. And it's just like so much more powerful, right? So I think that's a very different kind of like way of thinking about it. It's just like, what is the piece of text to copy paste to your agent? That's the programming paradigm now. I think one more.
Yeah. That is exactly kind of what I'm thinking. Like, he's basically saying that software, the LLM itself acting as a central unit, it have the knowledge about algorithms and both the knowledge about like how you know take the instruction from you, as saying, obviously if in English, let's say, then it have this knowledge to what to do with. So the age and basically goes up, okay, it knows about configuration about your computer and stuff like that. Then somebody gives certain information related skill is basically simple thing. It is a basically, you can think of it as a, I think it is a md file, .md file. There is a certain information in that file. That's it. It just load that file into LLM context, so that LLM have that information, so that it use it for do specific purposes. That's it. What skill is. So he is basically saying, okay, if computer itself become that intelligent, basically that intelligent basically means the LLM. If every computers have this the LLM present in every computer, then you don't need to specifically talk to the computer about like run this instructions, do this and do this. Bash script is basically if you're it is basically, if you're using Linux or Mac OS, you know what is bash is. It's basically what is the name for it? It is basically you can configure the I don't I just actually forgot the name for it. It just configuring the terminal. It is a interaction between the actual was thing. Oh my god, I just forgot that name. Okay, so I can show you mine, but not now. Okay, so it is a script. Basically, it executes. Yeah, you can tell the you can actually give the instructions about what to download and what are the things. There is a lot of them. Not only Bash, there is also ZSH, and there is also Fish or something like that. I'm using ZSH. So it is basically a script. You can say, okay, if you run that script, you can give anything in that script. Download this and start this and anything you can give. So terminal script. So before that is what's happening now. You give the enough information to a agent, so the agent will figure out what to do next. That is, I think that is what he is talking.
Or maybe example that comes to mind that is even more extreme than that is when I was building menu gen. So menu gen is this idea where you come to a restaurant, they give you a menu. There's no pictures usually, so I don't know what any of these things are. Usually, I like 30% of the things I have no idea what they are, 50%. So I wanted to take a photo of the restaurant menu and to get pictures of what those things might look like in a generic sense. And so I vibe coded this app that basically lets you upload a photo, and it does all this stuff, and it runs on Vercel, and it basically re-renders the menu, and it gives you like all the items, and it gives you a picture that it uses an image generator for to basically OCR all the different titles, use the image generator to get pictures of them, and then shows it to you. And then I saw the software 3.0 version of this, which blew my mind, which is literally just take your photo, give it to Gemini, and say, use Nano Banana to overlay the things onto the menu. And Nana Banana basically returned an image that is exactly the picture of the menu that I took, but it actually put into the pixels, it rendered the different things in the menu. And this blew my mind because
Okay, so this is what exactly he's talking about. Like before, he have this app, and you write you write the code, and you create the app, and it runs on a server. You send an image, and the back and forth the instruction is running. That is how it works. Now he's basically saying this LLM is act as a knowledge, right? So you don't have to like tell the computer, okay, what exactly it have to do. Instead, it have all the knowledge, so that it knows what you are asking, right? So it is like there is a yeah, it is like a baby and the person who's a 30-year-old, and telling the baby to go right and take this and come back to me. So the baby go right, it's because it doesn't have that whole knowledge about what to do next and stuff like that. This person who's 30-year-old and say go and take that, and it is very simple, right? He knows how to walk and stuff like that. And so so it may not be a perfect analogy, but that's how it is kind of like changing.
actually all of my menu gen is spurious. It's working in the old paradigm. That app shouldn't exist. Yeah, the software 3.0 paradigm is a lot more kind of raw. It just, your neural network is doing more and more of the work, and your prompt or context is just the image, and the output is an image, and there's no need to have any of the app in between. So I think that people have to kind of like reframe, not to work in the existing paradigm of what things existed and just think about it as a speed up of what exists. It's actually like new things are available now. And going back to your programming question, it's not even, I think that's also an example of working in the old mindset, because it's not just about programming and programming becoming faster. This is more general information processing that is automatable now. So it's not just even about code. So previous code worked over kind of like structured data, right? And you write code over structured data. But like, for example, with my LLM knowledge bases project, basically you get LLMs to create wikis for your organization or for you in person, etc. This is not even a program. This is not something that could exist before, because there was no code that would create a knowledge base based on a bunch of facts. But now you can just take these documents and basically recompile them in a different way and reorder them and create something that is new and interesting as a reframing of the data. And so these are new things that weren't possible. And so I think this is.
So he's basically talking about like you have the information and you have a LLM, and your AI agent or something like that. It reads the stuff and basically compress it or transform the information in a different way. So he's basically talking about, if you have a text, before you are write a coding, you write a program that converts that text into some different form. It is very difficult, and it is not there. You cannot do that. So now you give us some kind of information to your LLM, and you can do anything with it, right? You can modify it, you can add new ideas, and you can you can find mistakes and stuff like that. So this procedure about like transforming information into another form does not exist before in coding. So now we have this thing, and it is very powerful.
This is something that I keep trying to get back to, as to not only what can we do that existed that is faster now, but I think there's new opportunities of just things that couldn't be possible before, and I almost think that that's more exciting.
I love the menu gen progression and dichotomy that you laid out, and I think even, I'm sure many folks here followed your own progression of programming from last October to early January, February this year. If you extrapolate that further, what is the 2026 equivalent for building websites in the 90s, building mobile apps in the 2010s, building SaaS in the last cloud era? What will look completely obvious in hindsight that is still mostly unbuilt today?
Well, going with the example of menu gen, I guess, so a lot of this code shouldn't exist, and it's just neural network doing most of the work. I do think that the extrapolation looks very weird, because you could basically imagine, so you could imagine completely neural computers in a certain sense. You feed raw videos, like imagine a device, you take raw videos or audio into basically what's a neural net, and uses diffusion to render a UI that is kind of like, unique for that moment in a certain sense. And I kind of feel like in the early days of computing, actually, people were a little bit confused as to whether computers would look like calculators or computers would look like neural nets. And in the 50s and 60s, it was not really obvious which way it would go. And of course, we went down the calculator path and ended up building classical computing. And then neural nets are currently running virtualized on existing computers. But you could imagine, I think, that a lot of this will flip and that the neural net becomes kind of like the host process. And the CPUs become kind of like the coprocessor. So we saw the diagram of intelligence compute of neural networks is going to take over and become the dominant spend of flops. So you could imagine something really weird and foreign where neural.
Yeah. This is one of the very interesting idea he's talking about is that he's basically saying this. You have your computer, which is a calculator like computer, because you manually telling the computer what to do, and the another computer which is like your brain, right? So it has its own hardware, and it's so it is basically like, it is not like a general purpose computing. It is a general purpose thing, but it have the knowledge built into it. So this, it's not the first computer we have. The classical computer does not have any knowledge into it. It is basically execute certain information, instructions what you gave. But this, I'm not saying it is completely dumb. It knows how to add and stuff, because it have this, if you're into chip design, you know how these things are work. You have this ALU, arithmetic logic unit, and you have this bit patterns, and you merge them with the different gates, you get the output, right? So this is more like intelligence. It's like the intelligence itself packed into it, so that it knows what to do. So before in the classical computer, you are basically saying like, render this, and this pixel have to be this color, this pixel have to be this color, the image have to be present in here, and stuff like that. This is a instruction based. And this, you are saying this, but still it can render the image, render the image, and do your instruction, but in a intelligent way. It have that intelligence to basically render what's coming in. So it is like, so that is exactly what he's talking about. It is like, you can, I don't know, there is a good movie about like, oh my god, I just forgot the name of the movie, but it is really good. um and the actor name is like Oscar, um something like Oscar, and he's oh my god, it's a really good movie. Let's just say, list of AI films. It's somewhere around here. Iron Man 3, the British movie. No, this is not. I think it is. Yeah. This one is. Yeah. This one. Yeah, this movie. You know, if you look at this movie, it's really a great movie. I highly recommend to watch this movie. And you know in the end, the storyline is basically, there is a man who's a scientist, and he's running a company and stuff like that. And at some point, he's one Oscar Isaac. So at some point, he's basically have this hardware, and you know hardware which is glue like thing. It is a glue like thing. So it is a computer. So it is specifically built for the neural network. It is not like a general purpose and stuff like that. It is specifically for built to have intelligence itself. It is packed intelligence itself. So so it is more like your brain. So your brains knows what to do, because it is packed this algorithms, um lot of algorithms. You can think about it as the, let's say finding a phone is kind of like a recognizing a phone is a kind of like algorithm and stuff like that. Maybe you can think about it as a algorithm for recognizing things, algorithm for hearing things, algorithm for moving things. It is a you can think about it as a there are so many algorithms or knowledge packed into this single thing, so that it executes actions with that knowledge. So it is a really interesting idea.
Neural nets are doing most of the heavy lifting. They're using tool use as just like, historical appendage for some kinds of like.
I think at I think at some point you don't even need this kind of operating system and stuff like that. I think at some point you only need a script that loads this weights into your computer, so that the LLM itself running and acting and managing your memory system, like acting as operating system, doing your, reading your emails and reading your messages and stuff like that, and do the work, and it becomes a single unit. You don't need a extra, okay, I have this thing and that thing. Maybe you can just a single thing that enough to handle rendering, and obviously it is not possible today, I think. I'm not sure, but in future this is going to be a big idea, I think. And it is one of the this idea is basically blew my mind.
Deterministic tasks, but what's really running the show is these neural nets that are networked in a certain way. So you can imagine something extremely foreign as the extrapolation, but I think we're going to probably get there sort of piece by piece. And I don't, that progression is TBD, I would say.
I'd love to talk a little bit about this concept of verifiability. The fact that AI will automate faster and more easily domains where the output can be verified. If that framework is right, what work is about to move much faster than people realize? And what professions do we have that people actually think are safe, but that are actually highly verifiable?
So I spent some time writing about verifiability, and basically like traditional computers can easily automate what you can specify in code, and kind of this latest round of LLMs can easily automate what you can verify in a certain sense. Because the way this works is that when frontier labs are training these LLMs, these are giant reinforcement learning environments, so they are given verification rewards, and then
verifiability is one of the very important thing in this era, like AI era, because it is the core backbone of lifting this power of AI. Because without verifiability, it is really hard for you to create an AI model on a specific domain. Because you can think about it as art, right? So let's say there is a two person who is really good at art, doing drawing as art, painting or stuff like that. So after they finished, somebody say person one have a good art, somebody say person two have a good art, somebody say person and another person come, both of them have a good art painting. So you cannot verify that the value of that painting with some metric. It is really hard for you to do that, because both of them are really good at its own ways, right? It own ways, because it depends on the taste of the person, it depends on the view, it depends on the experience the person have. And it is not exactly like if somebody likes a painting, it is not true for everybody, right? They have specific taste and specific that. So in that domain, to basically verify which one is the best art is really hard for you to do, because you can't do that, because both of them are good in one ways. How do you measure how do you measure the beautiness of the art? You can't do that. So that is one of the open problems. So why AI is really good at coding? Because it is most of the time it can easily verify things. It can measure the output. It can show, okay, whether the output is right or wrong. So now you can think that is a really open problem right now. You can think of it as a debugging, right? Or once the AI code, AI write a code, like let's say if today you have a 10,000 lines of code, but you are not sure whether it have a bug or it is working fine. Does it introduce bugs and edge cases and stuff like that. You're not sure because unless you read it, you don't have any idea what exactly is it, because you cannot verify everything. That is the reason, because there is always something to break. So that is the thing I think about. The AI is really good at things that are easily verifiable and easily measurable. Like after this, with this metric, you can measure whether the AI is done a great job or not. If you have that, you can automate that domain with AI, I think.
Then, because of the way that these models are trained, they end up basically progressing and creating these like jagged entities that really peak in capability in kind of like verifiable domains like math and code and adjacent, and kind of like stagnate and are a little bit rough around the edges when things are not kind of like in that space. So I think the reason I wrote about verifiability is I'm trying to understand why these things are so jagged. And some of it has to do with how the labs train the models, but I think some of it also has to do with the focus of the labs and what they happen to put into the data distribution. Because some things basically are significantly more valuable in economy and end up creating more environments because the labs wanted to work in those settings. So I think code is a good example of that. There's probably lots of verifiable environments that you could think about that happen not to make it into the mix because they're just not that useful to have the capability around. But I think, to me, the big, I guess like the big mystery is the favorite example for a while was that how many letters are in a strawberry, and the models would famously get this wrong, and it's an example of jaggedness. The models now patch this, I think, but the new one is when I go to a car wash to wash my car, and it's 50 meters away, should I drive or should I walk? And state-of-the-art models today will tell you to walk because it's so close. How is it possible that state-of-the-art Opus 4.7 will simultaneously refactor 100,000 like line code base, or find zero-day vulnerabilities, and yet tells me to walk to this car wash? This is insane. And to whatever extent these models remain jagged, it's an indication that, number one, maybe something's slightly off, or number two, you need to actually be in the loop a little bit, and you need to treat them as tools. And
The jaggedness is basically like model is good at something at the same time worst at simple things. So he's basically like the model is really good at coding, but it is really bad at simple answer like a strawberry. How many hours in strawberry? If you ask the model to how many hours in the strawberry, it says something wrong. It gives you the wrong answer because it doesn't have that. It depends also on your data set, right? You have, end of the day, it is a single model, right? It's a single model, but you have this distribution of data, right? You need distribution of knowledge. You can think about it as okay, whether it knows about coding, whether it knows about language, whether it knows about culture, whether it knows about movies and stuff like that. So many variety of things, right? So the distribution, if the distribution is small, there is a highly likely chance that the model is not performing good at that the knowledge based tasks. So that is what his jaggedness is. So the jaggedness also introduced in two ways. One, the distribution is less because you don't have much data about that specific domain distribution of knowledge. And the second, you can't verify the quality of that distribution of knowledge, right? If you let's say you take a specific field and you want to train an AI model on it, and you can have a data, but you also need to have a way to measure the data. Okay, this is the right action to take, this is the wrong action to take. So that is the example I gave previously, right? There is a two painting. Both of them are good. Both of them are beautiful in own ways, but that's why you can't measure which one is beautiful, because for some person this one is beautiful, for some person A is beautiful, for some person B is beautiful. You can't measure it, the beautiness of art, with some metric. So in that case, A can't do anything because he does not have this algorithm or knowledge about how to predict this. End of the day, it's prediction, right? Even though AI and LLM, this fancy word means, but end of the day, token generator and predicting machine, probabilistic predicting machines, right?
You do have to kind of stay in touch with what they're doing. And so I think all of my writing, long story short, about verifiability is just trying to understand why these things are jagged. Is there any pattern to it? And I think it's some kind of a combination of verifiable plus labs care. Maybe one more anecdote that is instructive is from GPT 3.5 to GPT 4, people noticed that chess improved a lot. And I think a lot of people thought, oh, well, it's just a progression of the capabilities. But actually, it's more that I think this is public information. I think I saw it on the internet. A huge amount of data of chess made it into the pre-training set. And just because it's in the data distribution, basically the model improved a lot more than it would just by default. So someone at OpenAI decided to add this data, and now you have a capability that just peaked a lot more. And so that's why I think I'm stressing this dimension of it, as we are slightly at the mercy of whatever the labs are doing, whatever they happen to put into the mix. And you have to actually explore this thing that...
Honestly, this one is true, 100%. We are at the mercy of what the labs are doing, right? Because it is so expensive to make an AI model right now. It's really expensive, right? So you can't do that. Normal person can't do that, or even a small to medium startup can't do that. You need a ton of money to make these kind of models, right? So a ton of fundings and stuff like that. So we are mercy of this big labs, because we end of the day, the model going to be model we are gonna have is actually built by these frontier labs. So if they decided to model to be this and that, we have to accept it. There is no other way.
That they give you that has no manual, and it works in certain settings, but maybe not in some settings, and you have to kind of explore it a little bit. And if you're in the circuits that were part of the RL, you fly. And if you're in the circuits that are out of the data distribution, you're going to struggle. And you have to kind of figure out which circuits you're in your application. And if you're not in the circuits, then you have to really look at fine-tuning and doing some of your own work, because it's not going to necessarily come out of the LLM out of the box.
I'd love to come back to the concept of jagged intelligence in a little bit. If you were a founder today and thinking about building a company, you are trying to solve a problem that you think is tractable, something that is a domain that is verifiable, but you look around and you think, oh my gosh, well, the labs have really, really started getting to escape velocity in the ones that seem most obvious, math, coding, and others. What would your advice be to the founders in the audience?
So I think maybe that comes to the previous question of, I do think that verifiability, because it, let me think. So verifiability makes something tractable in the current paradigm, because you can throw a huge amount of RL at it.
So he's basically talking about reinforcement learning, where you have an environment and you have an agent. The agent take actions, and you have certain algorithms, like there is a lot of algorithms. And reinforcement learning, basically it takes the action, and with those metric and algorithms, it decides the action is right or wrong. Then it repeat those actions and optimize its actions in that environment. Then finally just optimize itself, then take the right actions.
So maybe one way to see it is that that remains true even if the labs are not focused.
It is very, what is it, is really very high level definition of reinforcement.
Focusing on it directly. So if you are in a verifiable setting where you could create these RL environments or examples, then that actually sets you up to potentially do your own fine-tuning, and you might benefit from that. But that is fundamentally technology that just works. You can pull a lever. If you have a huge amount of diverse data sets of RL environments, etc., you can use your favorite fine-tuning framework and pull the lever and get something that actually works pretty well. So I don't know what the examples of this might be, But I do think there are some very valuable reinforcement learning environments that people could think of that I think are not part of the, yeah, I don't want to give away the answer, but there is one domain that I think is very, oh, okay, sorry. I don't mean to vague post on the stage, but there are some examples of this.
On the flip side, what do you think still feels automatable only from a distance?
I do think that ultimately almost everything can be made verifiable to some extent. Some things easier than others. Because even for like things like writing or so on, you can imagine having a council of LLM judges and probably get something reasonable out of the from this.
So he's basically talking about the, I explained this idea previously. Like LLM judges mean, I can give you an analogy. Just like how there is a different peoples with a different taste, LLM can be at some point LLM also have a different gonna have a different taste and different background, different training, different knowledge, so that it picks things whatever it feels good, not feels good, things good. Maybe it feels good. I don't mind if we actually, maybe. So that is what Hud is saying. At some point, LLM is reasonably good, right? So if I think today's LLM also says good things about like very bad ideas, bad paintings, and stuff like that, because it doesn't have that such a taste in it. But in future, maybe it reached this reasonable amount of point where it tastes reasonably good, so that it picks it says some idea is really good, it says some painting or jokes is really good, that is decently good enough.
This kind of an approach. So it's more about what's easy or hard. So I do think that ultimately, yeah, I think
Everything.
everything is automatable.
Amazing. Okay. So last year you coined the term vibe coding, and today we're in a world that feels a little bit more serious, more agentic engineering. What do you think is the difference between the two, and what would you actually call what we're in today?
Yeah, so I would say vibe coding is about raising the floor for everyone in terms of what they can do in software. So the floor rises, everyone can vibe code anything, and that's amazing, incredible. But then I would say agentic engineering is about preserving the quality bar of what existed before in professional software. So you're not allowed to introduce vulnerabilities due to vibe coding. You're still responsible for your software just as before, but can you go faster? And
just simple. When you say add this feature to my code base to the AI, it's just vibe coding. When you say you can give specific informations and to the AI and basically execute this and stuff like that, add this, and you basically give the entire information, and still at the end you still review the code. It's basically agentic engineering. That is, I think, what is the difference. One, you just let the AI to do the job. Second, you kind of like managing the work, and you more of a like more of doing a work of examiner examining the code and managing the stuff.
And spoiler is you can, but how do you do that properly? And so to me, agentic engineering, when I call it that, because I do think it's kind of like an engineering discipline. You have these agents, which are these like spiky entities. They're a bit fallible, a little bit stochastic, but they are extremely powerful. And it's how do you coordinate them to go faster without sacrificing your quality bar? And doing that well and correctly is the realm of agentic engineering. So I kind of see them as different. Like,
so this transition is basically from vibe coding to agentic engineering. Is basically, I think agentic engineering is much more appealing than vibe coding right now, and people willing to believe agentic engineering because you review the code, you give the specific information, but at some point, maybe at some point, vibe coding itself is very believable if we have a way to measure measure or verify the output of the quality of the code. Sorry, quality of the code. If we have such a measure, probably one day, um, huh, we basically, at that point, I think that is the end game. That is the end game of developers like us.
One is about maybe raising the floor, and the other is about extrapolating. And what I'm seeing, I think, is there is a very high ceiling on agentic engineer capability. And people used to talk about the 10x engineer previously. I think that this is magnified a lot more. 10x is not the speed up you gain. And I think it does seem to me like people who are very good at this peak a lot more than 10x from my perspective right now.
I really like that framing. One thing that when Sam Altman came to AI Ascent last year, one memorable thing he said was that people of different generations use ChatGPT differently. So if you're in your 30s, you use it as a Google search replacement. But if you're in your teens, ChatGPT is your gateway to the internet. What is the parallel here in coding today? If we were to watch two people code using OpenClaw, Claude Code, Codex, one you'd consider mediocre at it, and one you would consider fully AI native, how would you describe the difference?
I mean, I think it's just trying to get the most out of the tools that are available, utilizing all of their features, investing into your own kind of setup. So just like previously, all the engineers are used to basically getting the most out of the tools you use. Either it's Vim or VS Code, or now it's Claude Code or Codex or so on. So just investing into your setup and utilizing a lot of the tools that are.
I can't believe he just mentioned Vim. Vim. I use Vim, by the way. Not exactly Vim, but Neo Vim, by the way. It's a meme, right?
Available to you. And I think it just kind of looks like that. I do think that maybe related thought is a lot of people are maybe hiring for this, right? Because they want to hire strong agentic engineers. I do think that what I'm seeing is that most people have still not refactored their hiring process for agentic engineer capability, right? Like if you're giving out puzzles to solve, then this is still the old paradigm. I would say that hiring has to look like, give me a really big project and see someone implement that big project. Like let's write, say, a Twitter clone for agents, and then make it really good, make it really secure, and then have some agents simulate some activity on this Twitter. And then I'm gonna use 10 Codex 5.4 X high to try to break your the website that you
That is actually interesting. Interesting take. He's
deployed, and they're gonna try to basically break it, and they should not be able to break it. And so
that is actually reasonably interesting way of interviewing a software development. Before it is solving a puzzle, now we are giving a code base to create. But obviously it is much more easier than before, because before you have to know every little details about what you're doing. Now you don't really have to. You have to know what are the tools, what are the things, what are the it is more like a before you also basically engineer, but also basically the person who's basically riding the boat or something like that. Captain at the same time, who's the person giving orders at the same time executing orders. Now you are more like who's the person just giving the orders. He doesn't know every little details, but if he knows, that is good. This is how you from assembly to C and C to Python. In Python stuff, but in Python doesn't give you the full knowledge about how computers actually executing information instructions, but assembly give you everything. You knows every little details, but Python is very different. That is how this thing's moving.
So maybe it looks like that, right? And so, yeah, watching people in that setting and building bigger projects and utilizing the tooling is maybe what I would look at for the most part.
And as agents do more, what human skill do you think becomes more valuable, not less?
Yeah, it's a good question. I think.
Yeah, obviously this is a really good question. Let's
Right now,
see
the
what.
answer is that the agents are kind of like these intern entities, right? So it's remarkable. You basically still have to be in charge of the aesthetics, the judgment, the taste, and a little bit of oversight. Maybe one of my favorite examples of like the weird
Yeah, the taste. I already mentioned that the taste is the only thing the A is really not good at that. They doing terrible job at it. The taste is not good. So, but even as average human in the world have a good taste. So, taste is something. Is maybe in future it's going to be a valuable skill.
weirdness of agents is
you know Still now, even in this today, even today, taste is really really valuable skill in a specific domains.
for menu gen. You sign up with a Google account, but you purchase credits using a Stripe account, and both of them have email addresses. And my agent actually tried to basically like when you purchase credits, it assigned it using the email address from Stripe to the Google email address. Like there wasn't a persistent user ID that for people. It was trying to match up the email addresses, but you could use different email address for your Stripe and your Google, and basically would not associate the funds. And so this is the kind of thing that these agents still will make mistakes about. Is like, why would you use email addresses to try to cross-correlate the funds? They can be arbitrary. You can use different emails, etc. Like this is such a weird thing to do. So I think people have to be in charge of this spec, this plan. And I actually don't even like the plan mode. I mean, obviously it's very useful, but I think there's something more general here where you have to work with your agent to design a spec that is very detailed. And maybe it's maybe basically the docs, and then get the agents to write them. And you're in charge of the oversight and the top level categories, but the agents are doing a lot of the under the hood. And so I think you're not caring about some of the details. So as an example also with arrays or tensors in neural networks, there's a ton of details between PyTorch and NumPy and all the different like pandas and so on for all the different little API details. And I already forgot about the keep dims versus keep dim, or whether it's dim or axis or reshape or permute or transpose. I don't remember this stuff anymore, right? Because you don't have to. This is the kind of details that are handled by the intern because they have very good recall. But you still have to know, for example, that there's underlying tensor, there's an underlying view, and then you can manipulate view of the same storage, or you can have different storage, which will be less efficient.
Yeah, this is the things. This is a good analogy, which is that there is a API thing, API knowledge you need to have. There is a thing what knowledge about what you need to do. So now people are moving towards you need to have a knowledge about what you need to do, but you don't need to exactly remember this knowledge about APIs, like what exactly this API and this function do and stuff like that. Now A is decently good at handling this job and not good at handling this job.
And so you still have to have an understanding of what this stuff is doing and some of the fundamentals, so that you're not copying memory around unnecessarily and so on. But the details of the APIs are now handed off. So you're in charge of the taste, the engineering, the design, and that it makes sense, and that you're asking for the right things, and that you're saying that, okay, these have to be unique user IDs that we're going to tie everything to. And so you're doing some of the design and development, and the engineers are doing the fill in the blanks. And that's currently kind of like where we are, and I think that's what everyone, of course, is seeing, I think, right now.
Do you think there's a chance that this taste and judgment matters less over time, or will the ceiling just keep rising?
Yeah, it's a good question. I would say, I mean, I'm hoping that it improves. I think probably the reason it doesn't improve right now is, again, it's not part of the RL. There's probably no aesthetics cost or reward, or it's not good enough or something like that. I do think that when you actually look at the code, sometimes I get a little bit of a heart attack because it's not like super amazing code necessarily all the time, and it's very bloaty, and there's a lot of copy paste, and there's awkward abstractions that are brittle, and like it works, but it's just really gross. And I do hope that this can improve in future models. A good example also is this, the micro GPT project, where I was trying to simplify LLM training to be as simple as possible. The models hate this; they can't do it. I kept trying to prompt an LLM to simplify more, and it just can't. You feel like you're outside of the RL circuits. It feels like you're obviously, you're pulling teeth. It's not like light speed. So I think I do think that people are still remain in charge of this, but I do think that there's nothing fundamental, again, that's preventing it. It's just the labs haven't done it yet, almost.
uh taste, I think taste is basically, at least for next 10 maybe 10 or 15 years, taste is going to be very important, because there is always something way better than previous. So that is even if you take, I can give you, if you take world best painting, it's not platinum out, it's not the best, it's the peak, it's not the peak of painting, right? There is obviously a lot of things, variety of things to do, maybe infinite amount of things to do in painting, right? So I think player taste is not um uh, 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 you know less over value, less over time, but I do think AI really gonna good at, each year it getting better and better. At some point, getting better at in taste, but but taste come from basically doing things, experience and stuff like that. But the experience itself for AI is basically came from the humans itself. So I'm not sure whether you know whether AI taste will be, surpass human tastes.
Yeah.
So I'd love to come back to this idea of jagged forms of intelligence. You wrote a little bit about this with a very thought-provoking piece around animals versus ghosts. And the idea is that we're not building animals, we are summoning ghosts. And these are jagged forms of intelligence that are shaped by data and reward functions, but not by intrinsic motivation or fun or curiosity or empowerment, things that kind of came about via evolution. Why does that framing matter? And what does it actually change about how you build and deploy and evaluate or even trust them?
I think the reason I wrote about this is because I'm trying to wrap my head around what these things are, right? Because if you have a good model of what they are or are not, then you're going to be more competent at using them. And I do think that, I don't know if it has, I'm not sure if it actually has like real power. I think it's a little bit of philosophizing. But I do think that, I think it's just coming to terms with the fact that these things are not, animal intelligences. Like if you yell at them, they're not going to work better or worse, or it doesn't have any impact. It's all just kind of like these statistical simulation circuits where the substrate is pre-training, so like statistics. But then there's RL bolting on top, so it kind of like increases the appendages. And maybe it's just kind of like a mindset of what I'm coming into, or what's likely to work or not likely to work, or how to modify it. But I don't know that I have like, here are the 5 obvious outcomes of how to make your system better. It's more just being suspicious of it and figuring it out over time.
That's where it starts. Okay, so you are so deep in working with agents that don't just chat. They have real permissions.
That idea about ghost and animals is, obviously kind of true, because this is the performance of AI and actions of AI depends on statistical things like data distribution and verifiable rewards and stuff like that. But animal intelligence is optimized for specific things like happiness and sadness, and so those things it have always have such a metrics all the times. It all the times whenever it take actions, it's always related to that metric. But for this, it is like a much more kind of like a jagginess. Like you can't say there is a specific matrix. It depends on the distribution and stuff like that.
They have local context. They actually take action on your behalf. What does the world look like when we all start to live in that world?
I think a lot of people probably here are excited about what this native agentic environment looks like, and everything has to be rewritten. Everything is still fundamentally written for humans and has to be moved around. I still use, most of the time when I use different frameworks or libraries or things like that, they still have docs that are fundamentally written for humans. This is my favorite pet peeve. Like, why are people still telling me what to do? Like, I don't want to do anything. What is the thing I should copy paste to my agent? Like, so it's just every time I'm told, go to this URL or something like that, it's just like, oh, you know. So everyone is, I think, excited about how do we decompose the workloads that need to happen into.
Because I think they do have those things, because those docs, because the people already know what to do is fine, but there is also this whole lot of younger generation who is learning stuff. They need to have such a documentation about why this how this works, why this is the case, why it is, and what it is, and how I can use it. They still need to read about it, right? So if they don't have it, obviously for someone who doesn't have such experience, doesn't have experience about these kind of things, they they're really gonna struggle with this, because the those things, if they only maintain for docs for AI, then obviously people who's doesn't have experience of use that tool gonna struggle.
To fundamentally sensors over the world, actuators over the world. How do we make it agent native? Basically, this.
My take on this have to be like, there is a that you have to be maybe you have to maintain both. You have a docs for human, you have docs for yeah, maybe you can give a more information in the docs for AI, maybe a decent amount of high level information for humans. That would be, yeah,
Subscribe it to agents first, and then have a lot of automation around, around data structures that are very legible to the LLMs. So I think, I'm hoping that there's a lot of agent-first infrastructure out there, and that for menu gen, famously, when I wrote the I'm not sure how famously, but when I wrote the blog post about menu gen, a lot of the work, or a lot of the trouble, was not even writing the code for MenuGen. It was deploying it in Vercel, because I had to work with all these different services, and I had to string them up, and I had to go to their settings and the menus, and configure my DNS, and it was just so annoying. And so that's a good example of, I would hope that MenuGen, that I could give a prompt to an
also, that is also what makes it so interesting.
LLM build MenuGen, and that I didn't have to touch anything, and it's deployed in that same way on the internet. I think that would be a good kind of a test for whether or not a lot of our infrastructure is becoming more and more agent native. And then ultimately, I would say,
I don't know, but the satisfaction of doing things, but at least for me, when I doing the hard thing, I feel more satisfied. But when I doing the easy thing, even though I'm doing it like 100 times, it just still, I don't feel that satisfaction. But if I do a one single thing which is really hard, and that is really satisfying. But the think about this agenticating and agentic coding, and vibe coding, this feels, the satisfaction of these things kind of like reducing than before.
I do think we're going towards a world where
reducing than before over time. Now it is, I would prefer coding manually if I need a satisfaction. If I want to get a job done, agentic engineering is better.
There's agent representation for people and for organizations, and I'll have my agent talk to your agent to figure out some of the details of our meetings or things like that. So I do think that
those other things are really good use cases, like talking to different services about like handling deals and informations and stuff like that. I really love to see AI on those fields. Like if I want buy a service in some service, and I have this amount of information, these are the things I like to do. Those things are really good. I like to see AI application in
that
those
that's
domains.
roughly where things are going. But
I really
yeah, I
excited.
think everyone here is excited about that.
I really like the visual analogy of sensors and actuators. I actually hadn't thought about that. That's super interesting.
Right.
Okay, I think we have to end on a question about education because you are probably one of the very best in the world at making complex technical concepts simple and deeply thoughtful about how we design education around it.
That is true.
What still remains worth learning deeply when intelligence gets cheap as we move into the next era of AI?
Yeah. There was a tweet that blew my mind recently, and I keep thinking about it.
Before seeing his take, let me say mine. So, which is that human brain is basically optimized. It is a thing that is learned through experience, right? So I would say, so what is the value, right? If you don't learn, if you don't have experience, then you don't learn. That's it, simple, nail it. If you don't, even though the intelligence become cheaper, you still need to know what to do, right? What to do, right? If you okay, there is a bike that can move and you can ride it, but that doesn't mean you don't know, you shouldn't know how to walk, right? Still you can use it for, you know covering distance, but you can still know how to walk and run, right? Sprint. And that is how I think. And unless someday you have a chip in your brain that directly that directly, like a copy paste the information to digital information to brain, if we reach such a point, we don't need experience, because you can just, transfer information really quick. You don't need to go through this experience. But until that point, you need experience, you need knowledge, you need some exposure to things.
It like every other day. It was something along the lines of you can outsource your thinking, but you can't outsource your understanding. And
I think that's really nicely put.
Yeah, because I'm still part of the system, and I still have to, somehow information still has to make it into my brain, and I feel like I'm becoming a bottleneck of just even knowing what are we trying to build, why is it worth doing, how do I direct my agents and so on. So I do still think that
I think, yeah, obviously, for me, I think the bottleneck is the information transfer between the brain and the information source, right? If you are watching this video, you are basically taking the information, right? But it is basically going through your eyes. So eyes only handle such a information, and there is a distractions, like you are hearing sounds and stuff like that. So the brain is the single source, but still it only take information in specific set of things, like eyes and hearing, seeing and hearing, and taste and stuff like that, sensing. So I think, if my previous idea, if we find a way to reduce that bottleneck, that is what makes this really, it's just insanely powerful.
ultimately something has to direct the thinking and the processing and so on. And that's still kind of fundamentally constrained somehow by understanding. And this is one reason I also was very excited about all the LLM knowledge bases, because I feel like that's a way for me to process information. And anytime I see a different projection onto information, I always feel like I gain insight. So it's really just a lot of prompts for me to do synthetic data generation kind of over some fixed data. So I really enjoy, whenever I read an article, I have my, my wiki that's being built up from these articles. And I love asking questions about things, and I think that ultimately these are tools to enhance understanding in a certain way. And this is still kind of like a bit of a bottleneck, because then you can't direct you can't be a good director if you still, because the LLMs certainly don't excel at understanding. You still are uniquely in charge of that. So yeah, I think tools to that effect, I think, are incredibly interesting and exciting.
I'm excited to be back here in a couple years and to see if we've been fully automated out of the loop and they actually take care of understanding as well. Thank you so much for joining us, Andrej.
Thank
We
you.
really appreciate it.
Well, it's a good talk, and it's yeah, Yeah, that is my take on Andre Kapati talk. And uh, if you're a developer and software engineer, um, who's worrying about losing job and stuff like that, and end of the day, you know it's about I think at one point A is really good at making software, and this operating system idea, like LLM is acting as a central unit, so you need to talk to it. And so I think at one point we would reach such a level, there is no need for coding and stuff like that. I would you know Coding means I'm talking about writing raw instructions, C press, maybe assembly, then C, Python and stuff like that. At one point you don't need to. At one point, you kind of like prompt is a better way to do it. And that is uh, that will happen, I think, because the capabilities of AI increasing over years. Not It's not gonna, okay, so we are going to, okay, that's it, this is the end. I don't think so. um but you know end of the day, I think it is good to have a joy of learning things. So if you have, then you are much more likely to perform things um, really good and have a satisfying life, because you can learn stuff, anything. But but I don't think people ever want to question about the concept of learning, because end of the day, you can't just say, okay, nobody wants to learn. You can't do that. You can't just say that. And people do need to learn, even though they have a calculators, even though they have a computers, even though they have anything. Unless some point you have your brain, you have a chip, you directly send a message to your chip with the certain information, then your brain remembers. We are not that point. We are so far away from that point. So until now, we have to learn. We have to you know do need to you know uh, uh, earn experience. And yeah, and this is it. And thank you for watching. See you in the next